Okay, let's talk about arithmetic sequence and series. So when we talk about a sequence, we're looking at a function whose domain is only the natural numbers. So the natural numbers are 0, or maybe not. Okay, here we go. 0, 1, 2, 3, 4, and so on. All right, so those are the natural numbers. Actually, it doesn't even include 0 because these are counting numbers and we don't learn to count with 0. So natural numbers start with 1 and move up. Arithmetic sequence has a constant difference between the two. So the domain, so these will represent our term numbers. And then the sequence with a constant difference, that's going to be our output. So they'll be like adding 3 to move through the sequence or subtracting 5. So you'll see that. All right, so let's look at this first set of numbers, and it's a sequence. And is there a common difference? So when I go through these numbers, what's the pattern? So that's what we're looking for first. So to get from 103 to 99, from 99 to 95, 95 to 91, what are we doing? We're subtracting 4 each time. So my common difference, which we just represent by D, is -4. All right, so if you are looking at your pattern, it's -4, -4, -4, and the next number is like 80, then no, this is not an arithmetic sequence. All right, so once we have the common difference and our pattern, could we find like the 100th term? Like I know I can find the 6th term. I'm just going to subtract 4 to get the next term, right? So when I'm talking about terms, this is the first term, second term, third, fourth, fifth. That is what these represent, right? So we use n to represent that number. So when you see n, that's what it's talking about. All right, so what if I want when n is 100 or the 100th term? I don't know about you, but I don't want to write all those numbers out. So we can come up with a formula. It's called an explicit formula, which will allow me just to plug in the term number that I'm looking for and find the value of that term number. All right, so here's how this works. So a sub n equals a sub 1 plus d times n minus 1. Kind of looks like an equation of a line, doesn't it? A little bit. All right, so let me explain what all of these letters stand for. So n is my term number, which we've already talked about. So these are called sub numbers. So you'll hear me say a sub n, a sub 1. Those just represent a specific term or a general term like this one. I don't have a term number, so it's kind of general. But when it says a sub 1 tells me first term. That's what that little 1 at the bottom stands for. All right, so let's see if we can put this arithmetic sequence that we were looking at in an explicit formula. So a sub n, which we're going to use 100 in just a second for that when I'm looking for the 100th term, is the first term plus the common difference. So my common difference is -4 times n minus 1. So remember, n is the term number that I'm looking for. All right, so we're going to clean this up. So a sub n equals 103. I don't need the plus minus, but I am going to distribute the -4 through, and I'm just going to remind you, when we distribute a negative through, it changes the signs of everything in here. And this time we're multiplying by 4. So minus 4n, -4 times a -1 is a positive 4. I can combine like terms. So a sub n equals -4n plus 107. Could you write 107 minus 4n? Absolutely. Usually I write the variable first. Totally up to you. So now with this explicit function, I can find the 100th term. I plug in 100 for n, I multiply it by -4, I add 107, and I have the 100th term. I could find any term that you're asking me to find without having to make a long list. So a sub 100 would look like this. This side is just notation, or you're just telling everyone what you're doing. We won't do anything with this side. So a sub 100 tells me I'm finding the 100th term. So -4 times 100 plus 107. So -400 plus 107. Since these guys are opposite signs we're subtracting, you're probably going to throw it on your calculator. So 400 minus 107. I don't have a calculator, so I'm going to do it by hand. Oops, that's a 2. My bad. So 293, and it's negative because the 400 is negative. So the 100th term, if I kept subtracting 4 all the way to the 100th term, I'm dipping into the negative numbers pretty far. So negative 293. All right, so that's an explicit formula or an explicit definition. Sometimes they'll call it a definition. So one more I want to show you is called recursive. So a recursive formula or definition means you're going to write a formula and it's going to depend on the term before. Like, what do I have to do to find the next term of this sequence up here? So I'm going to write it down here. So we had 103, 99, 95. All right, on that, I want to make sure 91. Yeah, they're subtracting 4. All right, so we subtracted 4 to get to all of these. All right, so let's write a recursive formula with this. All right, so a recursive formula is a piecewise function. All right, so my recursive formula looks like a sub n equals, right? Recursive formula, we start with the first term. So 103 when n equals 1. So this, I just put the first term on this line. Okay, so this is kind of going to feel like that gigabyte problem that we did. So there's my first term at 103. My second line is going to be how I find every term after that. So if this is my first term, how do I find this term? So that's a sub 2, right? This is a sub 3, this is a sub 4. So I find this term by taking the previous term and subtracting 4. Well, if I'm on term number 2 and I'm taking the previous term, my subscript looks like this. If n is 2, 2 minus 1 is 1. That pushes me back to the first term. If n is 3, 3 minus 1 is 2, pushes me back to the second term. I'll show you that in just a second if that doesn't make sense. So for these terms, I'm going to subtract 4, and that gives me that term when n is greater than 1. So that's a recursive formula. Recursive formulas are very limited. They can only find the next term. They can't find any term like the explicit formula is. Okay, so let me just quickly make this make sense. My first term is 103. That's a sub 1. My term number 2, if I put it in this formula, it looks like a sub 2 minus 1 minus 4. That means a sub 1 minus 4. So I pick up the a sub 1 term, which is 103. So I have 103 minus 4, which is 99. All right, I go to the next one. A sub 3. A sub 3, a sub 3 minus 1 minus 4. Remember, this is n, so I'm just plugging that in. A sub 2 minus 4. So I go back up here. This was a sub 2, so 99 minus 4 equals 95. Now, do we need to write out all of this? Probably not. We could just subtract 4 to get to the terms, right? But that's why we're doing that. That's what the recursive formula does. It takes the term before and applies whatever the rule is or whatever it takes to get to the next term. Okay? I know this is probably completely new, and that's okay. We're going to play around with it a little more when I see you again. All right, so those were sequences. Series, when we talk about series, we're adding the terms up. So I know you guys are going to be excited about this, but adding terms up is called sigma notation. I know. All right, so when we talk about sigma notation, this is a big symbol for sum. So just keep that in mind, and we'll talk about that when I see you again. Bye, guys.